Hello everyone and welcome to this tutorial. Today we are diving into the DSC function in PySpark which allows us to sort our data in descending order. Whether you're dealing with sales numbers, rankings or simply want to identify the top values in your dataset, sorting in descending order is a powerful way to make your data more informative and actionable. In this video, we'll explore how to use the DSC function effectively with practical examples. So let's jump right in. Introduction to the DSC function. The DSC function in PySpark is used to sort a data frame in descending order based on one or more columns. It is similar to using the SQL desc keyword in order by statements. This function is particularly useful when you want to prioritize or rank data, such as identifying the top performing products, the highest sales values, or the most recent events. By using descending sorting, you can easily focus on the largest or most significant values in your dataset, which is especially helpful when making business decisions or generating reports. For example, if you have a sales data frame and want to see which products have the highest sales figures, using desc allows you to sort the data in descending order with the highest sales values appearing at the top. This makes it easy to quickly identify the top contributors and understand where the most impact is coming from. Sorting in descending order also helps when analyzing metrics that you want to rank, such as highest scores, latest dates, or the largest quantities. Overall, the DSC function provides an effective way to arrange your data so that the most important or significant values are easily accessible. This makes analysis faster and more insightful, allowing you to understand your data better and focus on what matters most. Basic syntax. To sort a data frame in descending order using PySpark, you can use the order by function along with column name.desc. This sorts the specified column from highest to lowest values, similar to using desc in SQL. The column name parameter specifies which column to sort, and .desc ensures the sorting is in descending order. Using order by with descending helps highlight important records such as the highest sales or most recent dates, making the data more readable and easy to analyze for decision making. Why use desc function? Using descending sorting is extremely useful when you want to display the largest, most recent or highest values first. It is particularly effective when you need to rank items or prioritize data points, such as displaying the top sales figures, the latest transactions, or the highest scores. This is especially important in scenarios like financial data analysis, where identifying the highest sales or revenue numbers is crucial for decision making. Sorting in descending order also works well for creating leaderboards, highlighting top performers, or generating reports that require ranking. For example, you can quickly determine which products are performing the best, who the top employees are, or which events have had the most impact. Using descending allows you to focus on key values that represent the best or most important elements in the dataset, making analysis more efficient and insightful. It makes sure that the highest priority data is at the top, ensuring quick and easy access for analysis or presentation. Practical examples. 1. Sorting a column in descending order. In this example, we are working with a PySpark data frame DF containing sales data for different items. The data frame has two columns, item and sales. The item column represents various product names, and the sales column holds the corresponding sales values. Our goal here is to sort the data in descending order based on the sales column, allowing us to easily identify which items have the highest sales. To achieve this, we use the order by function along with df.sales.desc to specify that we want to sort the sales values from highest to lowest. The descending order helps us display the items that perform best at the top of the data frame, which is especially useful when analyzing sales data to identify top selling products. For example, if you need to understand which items are contributing the most to revenue, or if you want to generate a report showing the best performers, Sorting in descending order makes this analysis quick and clear. Using the .show function, we display the sorted data frame, making it easy to see the items arranged by sales values, with the largest figures appearing first. This approach provides a clear view of the best performing items, allowing us to make informed decisions based on the top sales contributors. Overall, this example demonstrates how to use the order by function with descending to sort a PySpark data frame. It's an effective way to prioritize and highlight the most important data points, making it easier to analyze high value items and draw insights from the data. 2. Sorting multiple columns with descending order. In this example, we are working with a PySpark data frame DF that contains sales data for different items. The data frame has two columns, item and sales. The item column represents the product names, while the sales column holds the respective sales values. Our goal is to sort the data first by the item column in ascending order, and then within each item, sort by the sales column in descending order. To accomplish this, we use the order by function and specify item to be sorted in ascending order, followed by df.sales.dsc to sort sales in descending order. Sorting by item in ascending order ensures that the data is grouped logically by each product, making it easier to compare the sales performance within the same category. Then by using descending for sales, we make sure that the highest sales value for each item appears first, which is especially useful when we want to focus on the top performing entries within each product category. This combination of sorting helps in understanding both the overall performance of different products and identifying which items have the best individual sales. It provides a clear ranking of sales values within each product group, making it ideal for generating reports or conducting analysis that requires insight into both group level and item level performance. Finally, we use the .show method to display the organized data frame. The resulting sorted data frame gives a well-structured view where each product category is presented, followed by the sales records in descending order. This makes it easier to analyze patterns and identify top performers within each product group. Overall, this example demonstrates how to use the order by function in PySpark to sort data by multiple columns with different sorting directions. By using ascending sorting for item and descending sorting for sales, we achieve a comprehensive, well organized view of our dataset that facilitates detailed analysis and better decision making. 3. Using DSC with multiple aggregations. In this example, we are working with a PySpark data frame DF that contains sales data for different items. The data frame consists of two columns, item and sales. The item column represents different product names, while the sales column holds their respective sales values. Our goal is to group the data by item, calculate the total sales for each item, and then sort the results by total underscore sales in descending order to easily identify the top performing products. First, we use the group by function to group the records based on the item column. By using aggregate with sum sales, we compute the total sales for each item, which provides an overall understanding of the sales contribution from each product. We then use the alias function to rename the aggregated result as total underscore sales. After calculating the total sales for each product, we want to identify which items have the highest overall sales. To achieve this, we use the order by function and specify total underscore sales with descending sorting. This ensures that the items with the highest total sales values are displayed first, making it easy to identify which products are contributing the most to the overall sales figures. Finally, the .show function is used to display the resulting data frame, which now presents the items sorted by their total sales in descending order. This provides a clear and concise overview of the performance of each product, allowing us to easily focus on the top selling items and make data driven decisions regarding inventory management, promotions, or other business strategies. Overall, this example demonstrates how to use group by, aggregate, and descending sorting in PySpark to effectively analyze and prioritize sales data. By grouping, aggregating, and sorting the data, we gain valuable insights into which products are performing the best, facilitating better decision making and more effective business planning. 4. Using desc with column expressions. In this example, we are working with the PySpark DataFrame DF that contains sales data for various items. The DataFrame has two columns, item and sales. The item column represents different product names, and the sales column holds their respective sales values. Our goal here is to sort the data based on sales values after increasing each value by 10% and then arrange them in descending order. To achieve this, we use the order by function in combination with an expression. The XPR function allows us to create an expression that multiplies the sales values by 1.1, effectively increasing each value by 10%. This calculation simulates a hypothetical scenario where sales have increased by a fixed percentage. By sorting these adjusted sales values in descending order, we ensure that the highest adjusted sales values appear first, making it easy to identify which items have the greatest potential after the increase. This kind of sorting is especially useful for analysis and forecasting. It helps you see how a small increase could affect the ranking of items or understand which products would benefit most from a boost in sales. Sorting in descending order allows you to quickly focus on the top performers, providing a clear and organized view of your data. The dot show method is then used to display the sorted data frame, which lists the items in order of their adjusted sales values from highest to lowest. This approach makes it easy to analyze which products could achieve the most benefit from a potential increase in sales and support strategic decision making by highlighting key opportunities. Overall, this example demonstrates how to use the order by function along with an expression to sort rows based on modified values in descending order. It provides a powerful way to understand different scenarios and identify top opportunities in your data, enhancing your ability to make informed decisions. 5. Handling null values with descending order. In this example, we are working with a PySpark data frame df underscore with underscore nulls containing sales data for different items. The data frame consists of two columns, item and sales. The item column represents product names, and the sales column contains their respective sales values, with some of the values being null. Our goal here is to sort the data based on the sales values in descending order while ensuring that the null values appear at the end of the sorted result. To accomplish this, we use the order by function with df underscore with underscore nulls dot sales dot desc underscore nulls underscore last. This means that we want the sales values to be sorted from highest to lowest descending, with all null values placed at the bottom of the data frame. Sorting with nulls last is helpful when you want to prioritize records with complete data, allowing for more meaningful analysis without the distraction of missing values. By placing null values at the end, you get a more organized and interpretable view of your data, where records with actual sales figures are prioritized. The dot show method is then used to display the resulting sorted data frame. This data frame will present the items in descending order based on the sales values, with any null values appearing last. This approach ensures that we can focus on the highest sales values first, making the analysis more straightforward, particularly when identifying top performing items or evaluating trends. Overall, this example demonstrates how to use the order by function in PySpark to sort data while managing missing values effectively. By sorting in descending order and placing nulls last, we create a well-structured data frame that highlights the key data points, facilitating easier analysis and helping you make informed decisions based on complete sales information. 6. Sorting strings in descending order. In this example, we are working with a PySpark data frame df underscore items that contains information about different fruits and their respective quantities. The data frame consists of two columns, fruit and quantity. The fruit column lists the names of the fruits, and the quantity column provides the quantity for each fruit. Our goal here is to sort the fruits in descending alphabetical order based on the fruit column. To achieve this, we use the order by function along with df underscore items dot fruit or desc. This means that we want to sort the rows in the data frame based on the fruit column, starting with the fruit names that appear last alphabetically. By using descending sorting, we can see the list in reverse alphabetical order starting from the letter closest to the end of the alphabet. This kind of sorting is useful when you want to present items in a reverse order or when you need to focus on specific entries at the end of an alphabetical list. Sorting fruits in descending order makes it easy to analyze the dataset based on the names of the items, especially when dealing with a large list where items need to be accessed in a specific order. It can also help when comparing items in a reverse sequence or preparing reports where alphabetical order is reversed for a particular reason. Finally, we use the .show function to display the resulting sorted data frame. The fruits are displayed in descending alphabetical order, starting with elderberry and ending with apple. This approach gives you a structured way to view the fruits based on their names, making it easier to identify or compare specific items within the list. Overall, this example demonstrates how to use the order by function with descending sorting in PySpark to arrange data based on alphabetical values in reverse order. It's an effective way to customize the presentation of your data to suit different analysis or reporting needs. Thanks for joining me today to explore how to sort data in descending order using the desc function in PySpark. I hope you found the examples helpful and that you can apply these techniques to make your data analysis more insightful. If you enjoyed the video, don't forget to like, subscribe, and hit that notification bell so you never miss out on future content. Feel free to leave your comments and questions below. I'd love to hear your thoughts or help you out with any issues you might be facing. Until next time, keep learning and happy coding.